Welcome to Program with Sam, and this is C++ Lesson 2. So today we're going to be looking at variables in C++, and this includes the primitive data types as well. And we'll be looking at some useful objects that are available in C++ as well. Now, in C++, we have access to the same data types that are available in C. So those being int, we have doubles, we have floats, we have bools, and we have char. So bool is a boolean, float is a floating point, double is a double floating point, and int is an integer. And if you've watched any of the previous videos, we've probably covered already, I think we did in Java, the amount of bytes used to represent these different data types in programming. So an integer can take any real value, any value without a decimal point. Double and float are for decimal points, but the number of places you want to go to will determine whether you use double or float. Boolean is just a simple true or false, and character or char is just an ASCII character like the letter A, and you would declare it by enclosing it in asterisks or asterisks, one of those two, like that. And a boolean you would declare as, say, true. A float you would declare as 0.5f, and a double would just be 0.5, and an integer would just be a number, so say 255. And that's how you would go about declaring those data types in C++. It's pretty much exactly the same as you would in C. And we'll come on to why that is later on. In addition to these sort of primitive data types, C++ gives access to a multitude of objects that come with the C++ standard libraries. We've seen sort of like this kind of thing before with Java, where you could just import a given library, a given jar file or whatever, and then utilize the objects from that given library. So in C++, we have access to something called strings. So we can say string, and we can say my string is equal to hello world. Obviously, it's throwing a hissy fit with the term string. That's because we haven't actually imported any string library. So if we just do that up there, it's still throwing up a fuss. And the reason for that is, as we discussed last time, we discussed all about namespaces. So for this one, all we need to do is using namespace std. And that should then set it green. And that means it's an object as opposed to a primitive data type. And so we're going to say my string is equal to hello world. And so that's one of the things that you can do with objects in C. But another one is from a library called vector. Now, vectors are very similar to some of the containers that we've seen before, or rather collections that we've seen before. So if you think of a collection as just an assortment of objects, sometimes they're enforced to be the same type, sometimes, like in Python, you can have varying. But I'd say the closest way to think of it is like an array list in Java. They're pretty akin to that. And so if you are coming from Java, vectors are probably going to be like your go-to for most stuff. I know that they are for me when I do things. So you can declare a vector by doing vector, and then if we say want strings, you could put anything in there. You could put objects that you've made if you wanted to, but for the purposes of this, we're going to do strings, and we're going to say my vector. And then if we want to push back, we can do my vector dot push back, and that will push back a string. So we can push back hello. So with our vector hello, space, and world all set up, what we can do is we can have this loop to print it out. So when we run it, it prints out hello world. Now what we can do is we could then pop off one. So if we then had my vector dot pop back, that should then just take the last element off. And we can then do vector dot pushback Sam. Then if we just copy and paste this code, potentially, if Visual Studio figured out what it was doing, and then if we give this a cheeky run, it should now just say hello world, hello Sam. And that's sort of like how vectors work and how you can use them in your application. It's worth noting that it's also possible to actually index vectors. So if we just did a simple for int I equals 0, I is less than my vector, not my string, my vector dot size I++, we would then be able to do cout my vector, and you could index it just as you would an array, and then at the very end do the endl, and that should resolve all the errors, and it should run exactly the same way as the previous loop. So it's worth noting that you can actually treat them as arrays in terms of indexing. So as you can see, C and C++ have a lot of overlap, or rather most of the parts that are of C are actually included in C++. And so to put it in perspective, and I've said this multiple times before, but you can think of C++ as a superset of C, or as I like to call it, the object-oriented expansion pack for C. And this means you can reuse a lot of the C concepts that we've looked at in the C series in your C++ code. And this is true even of comments. So by default with C++, we have access to two different comments. We have the single line comment, which can be done by just doing a double slash. This is a single line comment. Or you can do a multi-line comment. So that would be this is a multi-line comment. And that's a multi-line comment. And that can be used then to annotate your code and sort of describe which bits are doing what. And that way, when it comes for you reading the code, you can sort of see what you've written, and you can see, oh, I've written here that this function does XYZ and that function does ABC. So we know exactly what those functions are doing. If you look through the code, you'll be like, oh yeah, I see why it's doing that. And that's the purpose of comments, is because sometimes the code may be a bit unreadable, especially if you've got if statements with lots and lots of clustered ands and ors, this kind of thing. As a result, it's useful to then have these comments to just sort of clarify what it's doing, and you can then take it on faith that it's working, unless there is an error occurring, in which case you may come back and actually work through it logically. The last thing I want to touch on then today is going to be just sort of like the namespace here, because obviously at the start of the video we didn't have it and it wasn't recognizing string. So namespaces are very important for when you're using external libraries, because they will have a namespace that is required to be used. So whilst we're using namespace std because we're using the C++ standard libraries, it may be that with one of your projects you use a different library or an externally sourced library. For instance, recently I've been doing work on object recognition using Connect frame data as part of my degree. And one of the libraries that we're encouraged to use is OpenCV. Now, OpenCV is a great library even for image processing, and it comes with C++ and Python variants, as well as I think maybe MATLAB as well. But when you're using that external library, all of it is done under the namespace CV. So in addition to having your you're using namespace std, it's possible to also have other namespaces as well, like CV. Which is what my project utilizes, and as a result it's then able to use OpenCV functions as well as standard library functions without necessarily having to have the std : which is still perfectly correct even with the namespace, but the namespace just saves you writing that every single time. And to be honest, from what I've seen of code on GitHub and just in general, it seems to be a matter of personal preference. On GitHub, I think you find a lot of people just doing std : string, or and to be fair, you probably find it equally as common that people are just using namespace. I think it is just personal preference. I would imagine that there is some logic into using the std : method, and I would imagine that it's more to do with the fact that if you then develop your own libraries, or you're using lots and lots of namespace where there may be function or object overlap, in that case it's better to then just clarify which one you're wanting to use. So it's just something that you should bear in mind when you're working on your projects. That's it for this one. Next time we're going to be looking at declaring functions and defining functions, and we'll also take another look at recursive functions. If you'd like to follow me at ProgramSamBlog, or follow the blog directly at programwithsam.code.blog, that would be much appreciated, and I will see you in the next one.